All right, so we're going to go ahead and look at some questions out of 1.5. I'm not going to work these out completely. What I am going to do is set them up to get you to the equation so that you can then solve it. So we're going to start with question 3 out of 1.5. And so this is working with the square. And so what's special about a square is that all the sides are the same, right? So let's see how they relate. And this works with the area and the perimeter. And it says the area of a square is numerically 4 less than the perimeter. Find the length of the side, and it says if the side is greater than 1. So when we get our answer, we just need to make sure that whatever we get for our answer is greater than 1, and it will be. Now we don't have to worry about the 0. So area of a square, numerically 4 less than the perimeter. So let's start with that fact. So the area of a square is going to equal the perimeter minus 4. Is everyone okay with that? That's what it says. Area of a square, and yeah, we can all see it over here. Does anybody need me to move the television so we can see any better? Everybody can see it? All right. So area is going to equal the perimeter minus 4. Now, what do we know? We know that we have a square, and for a square, we know that all the sides are the same. So when we talk about the area of a square, that's going to be x squared. And the perimeter, we add up all the sides, and that's 4x. Is everyone okay with that so far? Now we'll fill it in. So we've got our area, which is going to be x squared. And that equals the perimeter, which we found, which is 4x, and then minus 4. It says the area of a square, that's that piece, is means equals, numerically 4 less than the perimeter. So that's going to be your perimeter minus 4. And you can finish it from here. Now, you're going to have to set it to 0 and solve it. Okay, and when you set it to 0 and solve it, you're more than likely going to get 2 solutions. And you need to make sure that the solution that you get is correct. So there's only one that will usually work on these. We want to get rid of the negatives, right? If we have a negative answer, it doesn't work because a length or a width cannot be negative. So you'll solve it out. You'll probably get 2 solutions. You'll want to keep the positive one. Question 4. The height of a box is 5 inches. Its length is 5 inches more than its width. Find the length if the volume is 120. So what we're going to need here is we're going to need some formulas. And we're looking at a box. So we're going to go to the back cover of our textbook. And since we're looking at a box, okay, that's going to be a rectangular solid. So that's what we're going to be looking at there. And so whenever you need a formula, just look in the back cover of your textbook. Okay, does anyone need the homework packet from last time? Everyone was here last time, right? Everyone has that? Okay. And what we're looking at is we're looking at some questions out of 1.5 from the homework. Right now we're looking at question 4. We're looking at a box, so a box looks like a rectangular solid. It's 3-dimensional, and we have a volume. And volume is a length times the width times the height. So let's go back and look at our question. Height of a box is 5. Length is 5 more than its width. So we're going to draw our box here. And we'll set this up. We know the height is 5. Okay. What else do we know? We know its length is 5 more than its width. So this is going to be x for our width. Length is going to be x plus 5. And we know our volume is given to be 120. And what is the volume calculated? When we calculate out the volume, that's the length times the width times the height. So we're going to multiply all these together. And that's going to give us now our volume. I will give you one more hint from here. Here's something that you can do to make your life a little bit easier. See that 5 out in front? Okay, 120 is also divisible by 5. So what we can do is we can go ahead before we do anything else and divide both sides by that 5. And that's going to make my numbers come out a little bit smaller. And 120 divided by 5, I believe, should be 24. So that's how you would come up with that equation. Now we need to solve it. You're going to solve it by setting it to 0. Use 0 factor. More than likely you're going to get 2 solutions. And only one of them is going to work. So you can finish it from there. And what do we know about the solutions? Can the solution for this be negative? No. Why not? Because x is a what? Is a width, right? So we cannot have a negative value. You're going to get 2 solutions, and only one of them will actually work. And that was question number 4. Question number 5 is going to be a Pythagorean theorem question, I believe. So a ladder is resting against a wall. The top of the ladder touches the wall at a height of 12 feet. Find the length of the ladder if the length is 4 more than the distance from the wall. So let's try to draw a picture here and try to understand what we've got. So I've got a wall here. This is my wall. And I've got a ladder that's on the wall. Okay, so it's against the wall. Okay, I'm going to try to maybe work on the side of a house, but this ladder is resting against the side of the wall. And we know that the top of the ladder touches the wall at a height of 12 feet. So that's going to be 12 feet there. So it's 12 feet from the ground to where it touches the wall, vertically. We don't know the length of the ladder, but we do know the length of the ladder is 4 more feet than the distance from the wall. So we don't know how far the horizontal distance is. So that's going to be our x. And we don't know the length of the ladder, but it says the length of the ladder is 4 more. So that would be x plus 4. Okay? Now, what kind of figure do we have here? We've got a triangle. When we have a right triangle, what can we use? We can use our Pythagorean theorem. So we go ahead and label these. And we need to make sure that the C is always the diagonal. That's the only important part. C has to be the hypotenuse or the diagonal. And we know that a squared plus b squared equals c squared. So now when we fill it in, we've got 12 squared plus x squared equals now x plus 4 quantity squared. I think you can finish it from there. How would we finish this one out? What would we have to do? We would begin by foiling. So we have to FOIL out the right-hand side, and we'll set it to 0. I can tell you on this one, you're not going to have to factor. This is actually going to come out to be linear because the x squareds are going to cancel. because you have an x squared in here, and that's going to cancel with that one. So you're only going to get one solution on this one. You're not going to have to factor it. This is going to have to be FOILed out here. So this has got to be FOILed. Combine like terms and see what you're left with. But the x squared should cancel out because you have one on the left and you'll have one of them on the right to cancel with. So you're only going to get one solution. The last one that we asked about was question number 9. And question number 9 is just making sure that we know how to plug the numbers into this formula. And question number 9 is compound interest. So let me try to put this on the screen so you can still see the rest of this equation if you need to. But let's go ahead now and look at question 9. So question 9 is interest. And this is compound interest. We've only covered simple interest so far. But in a later chapter, we're going to be looking at compound interest. So if an amount of money, called the principal P, is deposited into an account that earns an interest rate, R, compounded annually, then in 2 years, that investment will grow to amount A. And they give you the formula. If the principal is $5,500 and it grows to that $6,415.20 in 2 years, what is the interest rate? Okay. Now, it seems like there's a lot to do here, but there's really not. All we have to do when I see a question like this is I see, all right, I have a formula here. So I'm going to be using this formula. And all I need to do is figure out what piece goes where in this formula. So we're going to write up the formula, and we're going to label the pieces, and we're going to figure out what goes where. So here's our formula. A equals P times 1 plus R quantity squared. And this is question number 9, by the way. A is going to be the ending amount. P is the principal or the starting amount. So we've got an ending amount and we've got a starting amount. R is the interest rate, and that's what we're going to be trying to find. So A is going to be what we end up with. And in 2 years, how much money do I have? That's the larger amount. So in 2 years, I have $6,415.20. How much did I start with? Well, I started with $5,500. How am I going to solve this? Does anyone know where we begin to solve this? What property would I use? I can tell you it's not going to be zero factor. So let's talk about our properties that we have to solve this. Zero factor, quadratic formula, or the square root property. So it's not going to be zero factor. Okay, why is it not going to be zero factor? I could use zero factor, but that's going to be more difficult than if I try to use the square root property. Why? Why am I going to try and use the square root property? I'm going to use the square root property because that is by itself. I can get that by itself. So I'm going to do a couple more steps and I'm going to let you finish it. So what I'm going to do is I'm going to try and get this by itself so I can take a square root. That's going to be the easiest way to work with it. You could FOIL this all out, but you're going to end up with a page worth of work, when if I use the square root property, I'll be done in a few steps. So I'm going to go ahead and divide everything by this 5,500. That way I can isolate the square by itself. Now I have 1 plus r, quantity squared, equals, and we're going to divide out over here, $6,415.20. I'm going to divide that by 5,500. And that gives me now 1.1664. So all I did was I divided here, and I got to that point. Now, I am not going to finish it. You can finish it. How would you proceed? Now you kind of see what to do. How would you solve it? Well, it is set up now for the square root property, isn't it? Right? Because I can take the square root of each side, and then I get rid of the square, and then I can just move it over and solve. We've solved these back in 1.4. Remember these? Take your square root to get rid of that, and then just move that 1 over. So you can finish it from there. There's only one step left, but just take your square root. Don't forget the plus or minus. Now in this one, we're working with money, so we're going to end up using 2 decimal places, and we're going to get our interest rate as a decimal and turn it into a percent. So that's what we're going to do. Just take your square root. Don't forget the plus or minus. You're going to get 2 solutions. You only want the positive interest rate, not the negative one. So hopefully everyone's okay with that. So just take your square roots, add your plus or minus, and finish it. Now we're going to move on, and we're going to be looking at now 1.6. 1.6 is solving different types of equations. We're going to learn some different techniques and different equations that we're going to be solving here. So we're going to be solving equations that involve fractions, rational equations. Rational just means they've got a fraction involved. So we're going to be looking at some rational equations. We're going to be learning how to solve equations that have square roots. We've done squares, but not square roots. So we're going to deal with those. And then we're also going to look at ones that give us lots of solutions, where we have to factor with a little bit of substitution. So we're going to begin in 1.6. And in 1.6 on these, we're going to have to make sure that our answers work when we get answers. In many cases, we solve it and we get an answer, but it may not work because of division by 0 or a negative underneath the square root. So a lot of these we're going to have to look and see what our possible answers are. So the first thing we're going to learn about is we're going to learn about what numbers are not in the domain. And the domain is simply the possible values of x. And what we're looking for here is no division by 0. So we want, when we solve these out, we want no division by 0. Because division by 0 is going to make it undefined, and we cannot have an undefined answer. So we're going to look at these and see which ones are not possible solutions, which ones are not values in the domain. So I'm going to give you some of these, and we're going to find out what numbers are not solutions, not part of the domain. So here's our directions. Find the values that are not in the domain, not a solution. So not a possible solution. And we'll start off with this one that's pretty easy here. So what we've got, and we're not going to be solving this. Okay, so we're not solving these right now. We're just figuring out what numbers cannot possibly be an answer. Now, what we cannot have is division by 0. So what we need to do is we need to look and see where we would get division by 0. And so we look at our denominators. We don't care about the numerators at all. We only look at our denominators here. So we're only going to be looking at the denominators. And what we're going to do is we're going to set the denominators to 0. So we're going to set our denominators to 0. And we're going to figure out what numbers will not work. So if x plus 5 equals 0, then x equals a -5. So there's one number that's not in the domain. X minus 7 equals 0. That gives you x equals 7. And x plus 6 equals 0. Well, that gives you x equals a -6. And these are the values of x that are not in the domain. Okay, these are the ones that are not in the domain, not solutions. Because if I plug in a -5, what's going to happen? -5 plus 5, what does that give you? 0. And can you, bless you, can you take 5 and divide it by 0? No, because that's undefined. Same thing with 7. 7 minus 7 gives you 0 here. Doesn't matter what the value is on the top, but you cannot take anything and divide it by 0. Same thing with the -6. So those are the numbers that are not in the domain. Let's look at one more, and then we're going to learn how to solve these. So let's look at one more. We're going to find the values again that are not in the domain, not possible solutions. And you may have to factor. So I want you to look and see what numbers are not in the domain. And there's going to be 3 of them in this case. So what do? We look at our denominators, and we need to set each denominator to 0. So here's the denominator. Here's another one. And we're going to set each one to 0, and we're going to solve them. You may have to factor. And the first one is very simple, because it's simply going to be x equals 0. Right? Because if I plugged in 0, what would that give you? 5 divided by 0, and that's undefined. And we can't do that. What about the other one? This is going to require us to factor. Oh, well, let me change this. Make that the 7 and make this the 6. That way it'll factor correctly. My mistake. I just transpose those numbers. Make that the 7 and that the 6 on the end. Now to factor, because first times the last is a 6. And what 2 numbers give you 7? Should be pretty simple, 6 and 1, right? Okay, so that's now going to factor into x plus 6, x plus 1, and x plus 6 equals 0. So x equals a -6. And x plus 1 equals 0, so x equals a -1. So these are the values that give us division by 0. And that's important that we find them, because when we start solving equations in a moment, we need to make sure that when we get a solution, it actually works. And this is going to be the first step when we go to solve some of these. So now we're going to learn how to solve these rational equations. We're going to learn how to solve these rational equations. And these have a step-by-step procedure that we're going to follow. So to solve rational equations, step number 1 is find the numbers not in the domain. Step number 2 is you clear the fractions. So that's going to be our second step there. We're going to clear our fractions. Once we've cleared the fractions, then we solve the equation. And then finally, we check each answer with step 1. That's going to be our procedure. Find the values that are not in the domain. That means division by 0. We take them out first. We then clear our fractions and solve the resulting equation. And then the last step is we just check and make sure that it's not one of the values up here. So these are, in this section, a little bit time consuming. All the different types of equations. They take a little bit of time to go through and solve. So I'm going to pick some of these from our textbook to look at. That way they come out nicely. I'll do one easy one, and one of the more difficult. Some of them are a lot easier to solve than others. So find some here to solve. Let's start with the fairly easy one. How about we look at question 23. So this is going to be on page 164. We're going to look at question 23. And there's a step-by-step procedure that we're going to have to be using here. And I'll write it up here. If you don't have your textbook, that's fine. And it looks more complicated than what it really is. So whenever I encounter something like this, the first thing I need to do is I need to factor. So that may entail factoring as a difference of squares for here, or just factoring with this trinomial like we normally would. So the first thing we're going to do when we see this is we're going to factor. So we're going to break all this down as much as we can. So that's going to be our first step. So let's see how we can factor. So we're going to factor these out. So if I want to factor this, first times the last, and these factor out nicely, that's a -6. And what two numbers subtract from each other to give you 6? Subtract from each other to give you a 1, add or multiply together to give you 6. We're going to use a +3 and a -2, right? Because those go together to give you the -6, subtract from each other to give you the 1. So that's going to factor into x plus 3, x minus 2. So what we're doing is we're just simply factoring these denominators. The next denominator, x squared minus 4. Hopefully you kind of remember what are we going to do? We're going to look at this as a difference of squares. 4 is a perfect square. And so remember from your other courses, 4 is a perfect square. It's a difference of squares, so we break that up into x plus 4, x minus 4. And yes, this is actually one of the easier ones. Some of these get very complicated. I tried not to pick ones that were really difficult. So I tried to give you some easier ones. What about the other part? We've got x squared plus 5x plus 6. Well, we have the 6 in the box. And what two numbers give you the 5? Yep, 3 and 2. So that factors now into x plus 3, x plus 2. Now we're going to rewrite this all with our factored components. So we're going to rewrite it with our factored components. So now we've got, when I rewrite this, 4 stays the same. This broke down into x plus 3 down below, x minus 2. Then we've got minus 1 over x plus 2. Sorry, x plus 4, my mistake. Oh, why did I write 4? It should be a 2 there. Sorry about that. My mistake there, wasn't careful. Why should it be 2 here? Because, bless you, 4 is a perfect square of what? 4 is a perfect square of 2. I just wrote it down wrong. This is a difference of squares. 4 is a perfect square of 2. So that's where the 2's came from. That was my mistake there. Just wrote it down wrong. So that's plus 2, x minus 2. And then what is that going to equal? Okay, that's going to equal now 2 over x plus 3, x plus 2. So what we did was we took all those trinomials and that binomial and we factored everything. Now, what numbers are not in the domain? Let's go ahead and get that. This is step number 1 here. Not in the domain. Okay, what number is going to make it 0 here? Can someone tell me? What number, if I plug in and add 3 to it, is going to make it 0? Hopefully you can look at it and see what value is not going to work here. X equals a negative 3, right? Because that makes that 0. Can't have it. What about x minus 2? What makes that 0? 2, right? Okay. What about x plus 2x minus 2? Well, x plus 2, what's not going to work? Minus 2. Same thing over here. X minus 2, what gives you 0? 2. That's already taken care of. The 3 is taken care of here with the negative 3. And x plus 2, well, that's also a minus 2. Is everyone okay with why those are not in the domain? So what did we do? We set each denominator individually to 0. So that one, each part, that one gives you the minus 3, because that's 0. That one gives you the positive 2, because that's 0. Negative 2 doesn't work here. Positive 2 doesn't work there. Negative 3, okay. Negative 2. So those are the values that are not in the denominator. Now what we need to do is we need to see how we can clear out these fractions. So when we clear these out, we look and see, as a total, what do we have and how do we get rid of all the different parts? Okay, so let's look here. What do we have in our denominator here? We have an x plus 3 and an x minus 2. So out in front, I'm going to have to multiply this by an x plus 3, x minus 2. That's going to take care of that. Then I look over here. That x minus 2 is going to cancel there, but I also need to get rid of the other part, an x plus 2. Over here, the plus 3 and the plus 2 are already taken care of. So figure out what you need to clear out all the denominators. And now you distribute through. So Now we're going to distribute through, and we're going to see what we've got left. And things are going to cancel. We're going to write it out. We're going to get to our equation, and we're going to solve it. This one will be linear. That's why it's easier than some of the others. So we're going to distribute through. Okay, now what's going to happen here? Look at each part individually. Just look at this piece. What do we have? We've got an x plus 3, and it cancels with that. We've got an x minus 2, and it cancels with that. So what's left over that didn't get crossed off? We've got the 4, right? And an x what? Plus 2. Because that one went with that. That one went with that. So those are gone, and that's what's left over. What about the next part? We have a minus 1. And what happens on the next part? Those cancel, and those cancel. So what's left over? Minus 1 times x plus 3. And what about the last one? What happens here? Okay, we've got the x plus 3, x plus 2 are gone. So what's left over? 2. Okay, and those are gone. What's left with it? X minus 2. Is everyone okay with how I cleared that out? So now we've got something that we can solve. We know what to do from here. We just simply distribute through. Okay, so we distribute through. And when I distribute through, now what am I going to be left with? Now we've got 4x. 4 times 2 makes it an 8. Watch your negatives here. We've got a minus x, minus 3. Right-hand side, we have a 2x and a minus 4. And we're going to do another one of these. But what our steps are, and let's kind of keep the noise a little bit down so we can follow along. I don't mind if you talk a little bit, but just kind of keep it down a little bit. What we do is we figure out what numbers are not in the domain. Okay, then we clear our fractions. So this is how we cleared our fractions. We looked at it as a whole, and we figured out what we needed. So we need to get rid of this one, x plus 3, x minus 2. So that's there. This one, the x plus 2, we have to add that in. The x minus 2 is already here, so that's taken care of. On the last piece, the x plus 3 is taken care of. The x plus 2 is taken care of. Now, when we distribute it through, these are going to cancel. So across, we get to this part. Now we combine like terms. So 4 and a minus x, that makes it a 3x. And 8 minus 3, that makes it a 5. And that equals 2x minus 4. Move that 2x over. Move the 5 over as well. And now we're going to be left with x equaling a what? Looks like when I solve it, negative 9. Now, is negative 9 a possible solution? Is negative 9 going to work? Yes. How do I know negative 9 works? Because is negative 9 one of these three numbers? No. Now, if it would have been, let's say, a negative 3, this would have been a negative 3, it would be no solution. But negative 9 is not one of those, right? So it is in the domain. So your answer in this case would be negative 9. Now we're going to look at another one of these. The next one we're going to have to probably factor and work with. Let's look at question, how about 28? We'll look at 28 next year. They're all a little bit different. So question 28. And this is on the same page, page 164. Question 28. And this one's actually a little bit easier to set up, but we're going to have to factor it and work with it. So 28, we have a minus x over x plus 1 minus 1 over x minus 1, and that equals now a minus 2 over x squared minus 1. Okay, so we're going to try to solve this. Now, what's our step-by-step procedure? First thing we do is we find the numbers that cannot possibly be solutions. So what numbers are not in the domain? By the way, what does this factor into? Let's look at this piece right here. What is this x squared minus 1? What does that factor into? Does anyone know? Yep, very good work. That's a difference of squares. X plus 1, x minus 1, right? So that factors into that. So I can rewrite this as this. Right? Is everyone okay with that so far? So I factored it and it got to this point. Now, once it's here, what numbers are not in my domain? Can someone tell me? Hopefully now you can kind of look at it and see what numbers are not in the domain. Does anyone know what they might be? What number is going to make this 0? Yep, negative 1. So negative 1 is not in there. What about over here? Positive 1. So the numbers that are not in the domain are plus 1 and minus 1. Now we can start clearing our fractions. And we look at it as a whole again. So what am I going to need? I am going to need an x plus 1 and an x minus 1. Why do I need those? Because this one has an x plus 1, so that's why I wrote it out in front. This one has an x minus 1, so that's written out there as well. And then they both are here, so that's going to take care of everything. It clears out all of my fractions. Now we start distributing through. So we begin distributing through. So what's going to happen when I rewrite it? The x plus 1s, they cancel, don't they? Right? So that leaves you then with a minus x and an x minus 1. And we have a minus 1, and the x minus 1s cancel. Right? So that leaves you now with a minus 1 times x plus 1. And what about on the right-hand side? Those completely cancel, don't they? So what's left over? Negative 2. Now we've got our equation. Now we can solve it. They take a little bit of time to go through, and there's a step-by-step procedure that we use. Distribute through. Bless you. And let's see what we've got. Yeah, I use the x plus 1, x minus 1, because that clears that clears that, and these clear that. So now I've got, when I distribute through, we've got a negative x squared. Negative and negative make it a positive x. We've got a negative x here. Negative 1 distributed through makes it minus 1. And that equals our negative 2. Okay, let's focus back on kind of what we're doing here. And again, I don't mind if you had side conversations, just kind of keep them down a little bit. What's going to happen here? Okay, so I distributed that negative x through, and I distributed the negative 1 through. These can cancel. So now we've got a minus x squared minus 1 equals minus 2. So I can finish this. I'm going to use my square root property. So I'm going to add 1 to each side. Minus 2 plus 1 makes it a minus 1. Divide by your negative 1, and that leaves you now with x squared equals 1. And how do I get rid of a square? What undoes a square? Square root. And whenever I take a square root, I have to add in a plus minus, don't I? Now what do we have for my possible solutions? Square root of 1 is 1, so we have 1. And we have negative 1. Okay, why are these not going to work? We've got solutions, all right, but these both do not work. Why? Because what numbers can we not have? We cannot have, for our solutions, negative 1 and positive 1. Well, when we solved it, what did we come up with? Negative 1 and positive 1. So these don't work, do they? So what do we actually have for this one? No solution. Why not? Because these are not in the domain. Okay, these match up with that up here. That's why we have no solution. Now, it could be that both of them work. It could be that only one of them works, or in this case, none of them actually work. So this is one type of equation that we're learning how to solve. These are rational equations. Next, we're going to learn about equations that involve square roots. So we've seen the rational ones. We're going to do a couple that involve square roots. Okay. For equations that involve square roots, step number 1 is you want to isolate the square root. Step number 2 is how do we get rid of a square root? Let's think about how we got rid of a square. How did we get rid of a square? We took a square root, right? They're opposites. So what's the opposite of if I gave you a square root? Opposite of that would be square. So isolate that square root by itself if it's not already there. And then what you're going to have to do is you're going to have to square both sides. Then you solve. And then finally, you have to check each answer in the original question. Okay, so it's got another step-by-step procedure. Isolate that square root. So get it by itself, square both sides, then we solve the resulting equation. You might get one solution, might be linear, might be nonlinear where you get several. Then what you do is you have to plug each possible solution back in the original and check. Because chances are you're going to get two solutions, but only one of them might work. It might be that both of them work. It might be that neither one of them work. But you've got to plug it back in to see if it works or not. If you get a fraction, plug in the decimal equivalent and just see if the sides match. What you want to do is make sure the sides match at the end. And just like the rational ones, there are some easier ones and there are some more difficult ones to work through. I'm going to give you one of these to work on. So we're going to try and solve this one. How about we look at trying to solve, and I'll try to make sure it looks similar to the homework. I gave you those. Let's try to solve. How about question 46? So question 46 is going to be like what you're going to see in the homework. I only gave you 2 of them. But it's going to be very similar to what you got in the homework. So question 46. Okay, so question 46 here. What we have is we've got x minus the square root of 3x plus 18 equals 0. Okay, so we've got to follow our step-by-step procedure here. Now, what do we need to do? What does step number 1 say to do? It says to take this and isolate that square root by itself. So the first thing we're going to do is we're going to move this square root over so it gets by itself. And that leaves you with this. These are actually easier, I think, to solve than the rational equations that we just did. So the first thing I did, step number 1, was I isolated that root, so I moved it over. Now, how do we get rid of a square root? The opposite of a square root is a square. So we square both sides. So we're going to go ahead here and square both sides. Now, when I square a square root, it goes away. So on the left-hand side, this becomes x squared. On the right-hand side, what happens with the square and the square root? They're opposites, so they cancel. So that leaves you with a 3x plus 18. So you set the square root by itself. You square both sides to get rid of it. Now we can solve it. How would you solve this? And they should factor out nicely. You should not have to use the quadratic formula at all. Solve this by moving the 18 and the 3x over. And now we've got x squared minus 3x minus 18 equals 0. First times the last makes it a negative 18. What about the signs? Are they different or are they the same? Different, okay. And which one's going to be larger? Okay, because it's in the middle here. And can you tell me what 2 numbers it would be? Very good work. Yep, we need a negative 6 and we need a positive 3. Now we've got that. X minus 6, x plus 3. And be careful. Make sure you switch your signs when you solve it. Plug it or set it to 0. So x minus 6 equals 0. So x equals 6. X plus 3 equals 0. So x equals a negative 3. Now, we are not done yet. Okay, we got our 2 possible solutions. What we have to do is, because of the nature of the square root, we have to plug it in and we have to make sure that the sides match up at the end. In many cases, you're going to get 2 solutions, but one of them may not work. And I can tell you that one of them is not going to work. Just by looking at it. We're going to check it and see. Now we have to check each one in the original. Okay, so we take each one and we check it in the original. So we're going to check it in this. We're going to check it in the moved over right before we squared it, or you can check it way back in the original. Doesn't matter either way. We'll just go ahead and check this back into our original equation way back up here, or you could check it in here. But you want to make sure you check it in here. And let's start with 6. Now, one of these is going to work, one of them is not. Let's see if this one's going to work. Okay, 3 times 3 makes it 3 times 6 makes it an 18. And that's a 36. And what's the square root of 36? 6. And so does this work? Yes, it does. So this one works. The other one is not going to work, and you have to be very careful with the signs. So x equals 6 did work. Negative 3 is not going to work, and let's see why. When I plug the negative 3 in, our signs are not going to work for us because we're going to end up with not 0. We're going to end up with something else. So it looks like it might work, but let's check. We have a minus 3 minus 3 times negative 3 is a negative 9. Negative 9 plus 18 is a 9. Square root of 9 is 3. Okay, but this one doesn't work. Why not? Because that's negative 6, and negative 6 does not equal what? 0. So this one does not work. So what is the only answer? Okay, the only answer that we have is going to be x equals what? 6. The x equals that negative 3 does not work. Now, do not just assume that because it's negative it doesn't work. You have to check them. You have to physically plug it back in and check. You can't just look at the signs. So you always have to plug them back in, check and see. They may both work. It may be that neither one of them work. The next ones that we're going to look at are how to solve something with a fractional power. And these, I think, are some of the easiest. So I'll pick some of these that are pretty easy to work with. Question 85. And this is on page 166. And these are easy to solve, and these have fractional powers. It's actually very, very simple to solve. Now, how do we clear out fractions? Well, we multiply by the least common denominator, right? So we are going to get rid of these fractions. And the fraction happens to be a power. Whatever we do to one side, we do to the other. So let's go ahead and get rid of our fractional powers. So I'm going to do that by taking both sides to the third power. And you've got to make sure, here's where students make a mistake, you've got to make sure that you distribute your powers through. So how I got rid of them, okay, let's kind of focus on what we're working on up here, and you can look at things later on if you need to. But let's try to focus on what we're solving here today. So what we needed to do was we needed to clear out our fractions. These have a 3 down below. So if I cube both sides, that's going to clear my fractions. If I do that, what happens? The 3's cancel, and so that leaves you with an x squared. On the right-hand side, now here's where students make a mistake. That 3 has got to go through each part. It's not going to be 2 times 3, that's 2 to the third power. And 2 to the third power is 8. So this side is going to come out to be an 8, and the 3's cancel, x there. So we cleared out our powers. Now, you do not have to check these. So when you get your answers, you're done. You do not have to check them, because I was careful. I made sure I didn't give you anything that might possibly not work. These all work. So now how do I finish this? Okay, fractions are gone. Now we know what to do. We set it equal to 0. Nothing new here. And what can I factor out now? Okay, this should factor. I see what can come out. It looks like an x can come out, can't it? Right. So That's what we're doing here. Factor out that x. That's going to leave you with an x minus 8. And what are my two solutions going to be? Well, one solution, and don't forget about it, is 0, because that came from that piece right there. What about the other one? The other one is x minus 8 equals 0, and so x equals 8. We do not have to check these. You only have to check the fractions and the square roots. Fractional powers are okay, so you don't have to check them. These are our two solutions. We've got two more types of equations to look at. So a couple more questions, and that'll finish up our lecture for today. So not much is left. But I do want to do at least one of these. Okay, so one like what we've got here. Let me find a good one to look at. Question 89. So we're going to be looking now at question 89. The highest power tells you how many solutions you're going to have at most. So when we look at question 89, the highest power is going to be 4. So when we look at this, this is kind of like what we're used to working with. All right, but the only difference is, instead of it being a square, now it is a what? Power of 4. Okay, so we need to solve this like we would any other trinomial, but we're going to get 4 solutions at the end. So we're going to end up with 4 solutions total, but it's going to factor out and work like any other trinomial. So the first thing we do, just like any other trinomial, it's set to 0. So we take our first times our last. And the first times the last is a negative 15. Can someone tell me what two numbers are going to work here? Give me the 2 in the middle. Yep. We need a positive 5, right? And we need a negative 3, don't we? Normally, it would factor into x plus 5, x minus 3. But it's not x squared, it's x to the what? 4th now. So this is going to factor into x squared plus 5, x squared minus 3. So it's just got one extra small step here. This is where we're going to get 4 solutions. Each one of these is squared, so each one of these has 2 solutions. So that's going to give us a total of 4. Now we do each one. So x squared plus 5 equals 0. We're going to use our square root property. So we're going to move our 5 over. And that leaves me with, now, x squared equals a negative 5. And how do we get rid of a square? Remember this? Work in terms of opposites. We get rid of a square by taking a square what? Root. Okay. And remember back in 1-3, when we take the square root of a negative number, it comes out and it gives you an I. So this is going to come out to be plus or minus I square root of 5. And what would my 2 solutions actually be? Just so we have them. X equals I square root of 5. X equals negative I square root of 5. So there's 2 of them from this piece, right? 2 of them from here. Each one of these is going to give me 2 solutions. What about the other 2? Where are they coming from? Well, they're coming from x squared minus 3 equals 0. Same procedure. Add your 3. And that gives you x squared equals 3. And how do we get rid of a square? Square root. add on your plus or minus. So what are they if I write them out? X equals the square root of 3, and the other one is x equals minus the square root of 3. So there are my 4 solutions total. 2 from here, 2 from there. That gives you now your 4 solutions. And so there is one of those, well actually there's 2 of those in your homework, but they're same as what we just did. The only type of question that we have left is these applications. And we're going to be working with problems that involve work. And they're actually very simple to set up. They're actually easier than some of the other applications. So these are questions that involve work. And when we do these, we need to make sure that we set it up as how much is done per hour or per unit of time. So these we're going to have to work through, and they're very simple to work through. They're not difficult at all. Question 37. We're going to be painting a house. If Joe can paint the house in 3 hours and Sam can paint the same house in 5 hours, how long does it take them to work together? Well, we can't just add them together, right? Because if I added them together, what would you get? 8, right? But we know that doesn't make sense because Joe can paint the house by himself in what? 3 hours. So we know it has to be less than 3. Now, how do we handle this? Well, we need to look at it as how much is done per hour. So we take each one and we look at the fractional part that they do per hour. So let's start with what we've got. We've got Sam and we've got Joe, and they're going to be working together. And this, by the way, is on page 65. 165 here, and we're looking at question 37. So we've got Joe and we've got Sam. Now, how long does it take Joe to paint the house? Okay, by himself it takes him 3 hours. So how much is done in 1 hour? How much of the house is done in 1 hour? That's going to be 1/3, right? Because he paints 1/3 of the house in an hour. What about Sam? Sam takes him longer, 5 hours. How much is done for Sam in 1 hour? 1/5. Is everyone okay with that so far? Now we put them together. And we don't know our time, so our time is going to be the unknown, and that's our variable x. And now we multiply these together. And we've got Joe, and we've got Sam. And Joe, we use our fractional conversion here. So 3 hours means we did 1/3 in an hour, so that's 1/3 x. Sam, 5 hours, he does 1/5, which is less. So that's 1/5 x, and it always equals 1. Why 1? Because this is 100%, or 1 house. It is always, always, always going to equal 1. No matter what it is, it's going to be 1. Because you're either filling 1 pool, cleaning 1 house, painting 1 house, doing 1 tax return. Whatever it is, it's going to equal 1. 100% or 1. Now we can clear this out. Very easy to solve. How would we clear out our fractions? What would we multiply this by? Does anyone know what we would do here? To clear my fractions, I'm going to multiply it by what? Yep, which is, in this case, 15. Yep, so don't make this one more difficult than what it needs to be. Distribute through. 15 divided by 3 is a 5, so that's a 5x. 15 divided by 5, well, that's a 3. Let's bring the x down. And 15 times 1 is a 15. Add those together, and we get 8x equals 15. Divide by our 8, and we now have our answer, which is 15 over 8. And this is going to be in terms of hours. You could convert that to minutes if you want to. But let's see if this makes sense. Okay, why is this going to make sense in this talk about? What's the decimal equivalent of 15 eighths? Well, 15 eighths as a decimal is 1.875, right? Now, if Joe is by himself working on this house, how long should it take him? 3 hours. We know our answer has to be what? Has to be less than 3, because he can do it by himself in 3 hours. Now he has a helper. The helper takes 5 hours. So we know our answer has to be somewhere between 3 hours and an hour and a half. Why? Because if there's 2 Joes working on the house, that's an hour and a half. Because you'd half that 3, you get an hour and a half. So our answer needs to be between 1.5 and 3 hours. Is it in that range? Yes, so we know that we did it correctly. But that's how you can look at it and check. And you can convert this into minutes if you want to, but you don't have to. You can leave it as a fraction and leave it as it is. Now, why is it plus? Why are we adding these together here? We're adding these together because they're helping each other. If they were not helping each other, if they were hindering each other, it would be a subtraction. So let's work one more question out. And this one's going to be a subtraction question. And I'm going to go ahead and also pass out the sign-in sheet before I forget. Here's the sign-in sheet. Just make sure you sign that. And if you didn't pick up your homework or you turned things in, I have all of it graded for you to pick up today as well. But we're going to do one more quick question. Sure. How do I get the 15? Okay, the 15 came from the least common denominator of 3 and 5, right? So that's where that 15 came from, because that's the least common denominator of 3 and 5. And they're adding together because they're working together. Now the next one, they're going to be subtracting from each other. Question 41. We're going to be trying to fill up a swimming pool. So an inlet pipe can fill Blake's pool in 5 hours. The outlet pipe can empty it in 8. In his haste to surf the internet, Blake left both pipes open. How long is it going to take to fill up this pool? So when we look at this, we need to make sure we understand that this is going to be a subtraction problem, because we've got water coming in to a swimming pool, and we've got water going out. So this one's positive, this one's negative, because this is the drain down here. So what do we know about filling the pool? Okay. It says it takes him 5 hours to fill the pool. So how much is done in 1 hour? How much of this is filled? 1/5. We don't know the time again, so we use an X. What about when we drain? Okay, when we drain the pool, it takes 8 hours to drain. And so that means 1/8 is done in 1 hour. Okay, time again is X. Now, We are going to put these together, but one is positive because we're filling. The other one is negative because we are draining. So when we write up our equation, what is our equation going to look like? Well, it's going to be 1/5 x, right, minus 1/8 x because you're draining it out, and it's going to equal 1. Always equals 1. Why is it always going to be 1? Because we are filling up one swimming pool. We are mowing one lawn. We are cleaning one house. We are painting one house. It is always going to be 1 because that is 100%. Now we can clear this out. The least common denominator of 5 and 8 would be what? Can someone tell me? The least common denominator of 5 and 8 would be a 40, wouldn't it? Okay, so we're going to multiply all of this by 40. And then we'll solve. So 40 divided by 5, well, 40 divided by 5, that leaves you with an 8x. We got a minus. 40 divided by 8, that's a 5x. And 40 times 1, that's a 40. Combining those together, we get 3x equals 40. Divide by your 3. That leaves us now with our finished answer, which is 40 over 3 hours. Okay, so 40 over 3 hours then. And you can check it if you want, because 40 over 3 would be 13 something, if I remember right. Yep, 40 over 3. If I write it in here right, 40 divided by 3, yep, is 13 1/3. Okay, and that's definitely more than 5, right? Because it takes 5 hours to fill it up, but I'm also draining, so it's going to take longer. So that means our 13 1/3, or 13.3, that's going to work because it's bigger than the 5. Because you're also draining at the same time. So eventually it's going to overflow. So please make sure that you sign that sign-in sheet. And your homework for next time is going to be finish up that packet. So finish up that 1.6. Yep, it'll be due on Tuesday. And if you don't get it all finished, you can have till Thursday. But try and get as much of it done as you can. Because on